So for this conservation of energy question, all right, you got a lot going on. You got the mass of an object, goes down the hill. The hill is 100 meters long. There's a vertical drop from 36 meters. A seagull comes by, knocks it out. Okay, and at point A, the object has a velocity of 12.5 meters per second. They want to know what the velocity is here. So you have an initial height, an initial velocity, a final height, and a final velocity is what we're looking for. So I wrote over on the side, mechanical energy, since we know both of these, we can find kinetic and potential. So we know that the left side of the equation has to equal the right side of the equation. And we break that down even further into its basis here. Kinetic energy is 1/2 mv initial velocity squared plus m times g times initial height is equal to, all right, the final and the finals. So I wrote over here, because we're dealing with the same object and the masses are the same, we can cancel out the m's. In this problem, we can cancel out the m's. Cool. Next thing I tell you to do is g is 10, and now put in all your numbers and multiply. So let's do that. Let's put in all of our numbers. We're going to write in 1/2. Write small because there's going to be a couple steps in lines that we got to do. 1/2. What is the initial velocity that I have written? Is 12.5. So you're going to write 12.5. And since velocity is squared, you have to square that. Good. That's first. Now bring down my plus sign. Gravity. We're using 10 for gravity. I said g is 10. So 10 times, what was the initial height? hi. 36. Good. Equals. Bring down the equal sign. Right. We don't know what VF is, so we have to leave it like that. So you're going to write 1/2 VF squared. Bring down the plus sign. G times H. G is 10. And the final height we have is 9.5. All right. So if we scoot back over, put in the numbers, multiply, and then it says add if you can. So first thing you're going to do is multiply all these things. All right, 12.5 squared. In your calculator, multiply that, and then cut it in half. You should come out with this value, 78.125. Bring down the plus sign. 10 times 36, 360. Equals. We still don't know what this is, but we can't do anything yet. You don't do anything yet until you've got this entire thing isolated. So I don't want you multiplying by 2 or anytime just yet. Just keep this all together for right now. Good. And what's 10 times 9.5? 95. So I wrote here, all right, G, if we're using gravity is 10, put in the numbers, multiply. Then add if you can. So let's simplify the left side of the equation. Throw these two into your calculator, and you get a value of 438.125, and that equals this 1/2 VF squared plus 95. All right. So then what I wrote is subtract, so you're just left with this 1/2 VF squared on the right side. So what we're going to do is to get rid of this 95 on both sides, you got to subtract. So we're going to subtract by 95, subtract this by 95. Okay, putting that into the calculator, this number comes out to be 343.125, and that is going to equal our 1/2 VF squared. All right, cool. We got 2 steps left. To get rid of this 1/2, what does it say? It says multiply both sides by 2. So when I do a times 2 underneath that, it's going to get rid of this 1/2. So you got to multiply this here by 2. 343.125 times 2. This is going to come out to be 686.25. And now the 1/2 is gone, and that leaves us with VF squared. Cool. And then I wrote, to get VF by itself, you have to square root both sides. So when you square root something that's squared, that disappears. And so VF comes out to be, roughly 26.2. So if you take the square root of 686.25, we get 26.196 and other change. So if we were rounded to try and do 2 decimals, the 6 is going to bump it up anyway. So we're going to write 26.2. And the unit for velocity is meters per second. And that will be how you solve the next problem as well.